What are turbulent eddies in fluid flow? Imagine watching a fast-moving river where water swirls and twists in unpredictable ways. Those swirling motions are what we call turbulent eddies. They are tiny or large whirlpools that, from within turbulent flow, which is a type of fluid movement marked by irregular changes in speed and pressure. To understand turbulent eddies, think about the difference between smooth and chaotic flow. In smooth or laminar flow, the fluid moves in neat, parallel layers with little mixing. But in turbulent flow, the fluid particles move in complex, three-dimensional paths that twist and turn. These movements create eddies of different sizes, from big swirling masses to tiny vortices. Eddies form because of flow instability. When the forces pushing the fluid forward, called inertial forces, become stronger than the forces resisting flow, known as viscous forces, turbulence kicks in. This transition usually happens when the Reynolds number, a number that compares inertial and viscous forces, exceeds about 2,000. Once that happens, the flow becomes chaotic and eddies start to appear. Large eddies contain most of the energy in the flow. These big swirling motions break apart into smaller eddies through a process called the energy cascade. This process continues until the eddies become tiny, and their energy is dissipated as heat due to molecular viscosity. This hierarchy of eddy sizes is a key feature of turbulence and influences how fluids behave in many situations. In mechanical engineering, turbulent eddies are very important because they improve mixing of fluids and boost transfer of heat and momentum. For example, in engines, eddies help mix fuel and air more thoroughly, leading to better combustion. In pipelines, they increase friction but also prevent sediment buildup and help transfer heat more efficiently. To sum up, turbulent eddies are swirling, chaotic motions within turbulent flow that cause irregular velocity changes and mixing. They form when inertial forces dominate viscous forces, creating a cascade of vortices of different sizes. These eddies play a big role in many practical systems involving fluids, from engines to weather patterns, making them a fundamental part of fluid mechanics.